throwing the object in a projectile motion, after identifying the components of the projectile motion, next is to identify the equations to be used in projectile motion. And unlike the translational motions and the free fall motions, which we use the same equations. Okay, this time, so since projectile motions has two components, the x and y components, so in projectile motions, we are also using different equations in each component. So we have, these are the equations or the basic formulas to be used in the projectile motion. So as I have mentioned kanina, there is a separate equation for the x component or the horizontal components, as well as a separate equation for the y component or the vertical component. So for the horizontal component, we have the first equation, which is the equation for the initial velocity of the x component. The Vix is equal to cosine theta times the initial velocity. And then we also have the dx, or the distance on its x component, or the horizontal distance, is equal to Vix times time. So these are the equations to be used in the horizontal component. So first, we have the initial velocity x component, which is the Vix. So Vix is equal to cosine theta times the initial velocity. So I repeat, theta is the angle of inclination of the object from the horizontal. Then second, we have the distance on an x component, or the horizontal distance. So dx. So dx is equal to Vix times time. And next, we have the equations for the vertical or the y component. So first is the initial velocity on its y component. So we have the VII. So VIY is equal to sine theta times the initial velocity. Okay, next. So I think you are familiar with this remaining equation. The second equation, the acceleration. The third equation, the time-independent equation. And fourth is the displacement equation. So I think you're already familiar with these three equations, since we are using these three equations in the free fall motions. Okay, so the only difference is that the variable we are using this time has a subscript of y, since this is the y component of the projectile motions. So I think I hope you'll read you can still remember the difference and the how to use and when to use acceleration formula, the time displacement formula, and the acceleration formula, the time independent formula, and the last is the displacement formula. So I hope you can still recall how and when to use these equations. Okay, so these are the basic formulas to be used in the projectile motion. So if you can uh, observe, or if um, you can see the equations that we are in horizontal formula. Before you can solve for the horizontal distance, first is you need to solve, or it is a must to solve for the initial velocity on its, or for the x component initial velocity, as well as for the vertical component. So it is a must to solve for the VIY before you can solve for, or before you can apply the second, third, and fourth equation. So it is a must to solve for the VIY, or the initial velocity on its y component, as well as for the VIX, or the initial velocity on the x component. So then let's proceed with an example in applying these equations or these formulas in a given problem. Okay, so a ball is thrown from the top. Ball is thrown horizontally from the top of a 55-meter building with an initial velocity of 12 meters per second. So what is the distance covered by the ball from the base of the building if it travels 8 seconds? So ito yung sabi ko kanina. So the object, or the angle theta, is the angle of inclination of the object from the horizontal. So when we say from the horizontal, it is not always from the ground, because there are some instances where the uh, object, or the person applying a projectile motion, is on the top of a building, or it could be na nakapatong siya sa kung saan. So that is the reason that is not always on the ground. So for example, in this case, the ball is thrown horizontally from the top of a building. So it is thrown from the top of a building. So if this is the building, okay, so somebody is on the top of the building and he throws the ball horizontally. Okay, so he is on the top of the building and he throws the ball. Okay, he throws the ball horizontally. So throws the ball horizontally. So if you throw a ball horizontally from the top of a building, so there, since we have a gravity, so therefore the ball, though you throw a ball horizontally, or you throw an object horizontally, so the object still, or moves downward, since there is a gravity pulling the object downward. So the initial velocity applied on the ball is equal to 12 meters per second. So what is the distance covered by the ball from the base of a building? So the distance, so we are looking for the distance covered by the ball from the base of the building. So the distance from the base of the building, so from the bottom of the building, or the base of the building, to the final position of the ball. So that is, so we are looking for the distance, or the horizontal distance, or simply we are looking for the d sub x. And the time interval, so the time interval uh, during that is equal to 8 seconds. So therefore, we have our given. We have the velocity or the initial velocity, which is 12 meters per second. The time is 8 meters per second. Okay, the time is 8 meters per second. The time is 8 seconds. Okay, gravity. So since the object is moving downward, so therefore the gravity is positive. So I think I already um, explained this during the free fall motion, that if the object is moving upward, then the gravity is equal to negative. And if the object is moving downward, so the gravity is equal to positive. And since in this case the object is moving downward, so gravity is positive. Okay? And angle theta is equal to 0. So sir, bakit siya naging 0? So since the ball is thrown horizontally and angle theta is the angle of inclination from the horizontal, and the ball is thrown horizontally, so therefore since it is horizontally, okay, is thrown horizontally, so therefore it is parallel to the horizontal, or it is parallel to the x-axis. So therefore, if it is parallel to the x-axis, so it has no angle of inclination. And that is the reason that the angle theta is equal to 0. And so, since we are looking for the d sub x, we will use the equation for d sub x, which is the vi times time. But as I have mentioned kanina, before you can solve for the d sub x, it is a must for us to solve for the vix, which equal to cosine theta times vi. So before we solve for the dx, first is we need to solve for the vix. So let us solve for the vix using cosine theta times vi. So substitute cosine theta, theta is equal to 0, and the initial velocity is equal to 12 meters per second. So cosine 0 is equal to 1 times 12 meters per second, that is equal to 12 meters per second. So that is the value of our vix. And next, after you solve for the value of our vix, next is to solve for our dx using dx is equal to vix times time. So since vix is equal to 12 meters per second and time is equal to 8 seconds, so therefore 12 meters per second times 8 seconds, that is equal to 96 meters. Okay? Next is to apply the rule in significant figure. So since the least number of significant figure based on our given, so from 12 meters per second and 8 seconds, the least number of significant figure is only one significant figure. So we round 96 to one significant figure, and that is equal to 100 meters. And so, the distance covered by the ball from the base of the building is equal to 100 meters. Okay? So let's proceed with the next example. A ball is launched at an angle of 60 degrees from the horizontal, so with an initial velocity of 30 meters per second. So first question is, what is the ball speed to the highest point? So the ball speed, what is the ball speed to the highest point? Okay, second question is, what is the maximum height reached by the ball? So these are the two questions, A and B, which will solve. So first is, what is the ball speed to the highest point? And next is, what is the maximum height reached by the ball? So to understand it better, so we will illustrate the problem. So if this is the person throwing a ball at an angle of 60 degree, so the angle of inclination from the horizontal is equal to 60 degree, and the initial velocity is equal to 30 meters per second. Okay, the question is, what could be the ball speed to the highest point, and what is the maximum height reached by the ball? So this is for the letter B, which is the d sub y. Okay, the d sub y. And for letter A, the ball speed to the highest point. So since we are referring for the speed of the ball to the highest point, so we are referring for the vertical velocity of the object. So we are looking for the VI y, or the initial velocity of the object on its y component, or the vertical component initial velocity. So that is for the letter A and for letter B. So first, let us solve for letter A using VIY is equal to sine theta times the initial velocity. Okay, so sine theta is equal to VI. So theta is equal to 60 degree, and the initial velocity is equal to 30 meters per second. So if we input this in our calculator, that is equal to 15 square root of 3 meters per second, or in decimal, it is 25.98 and so on. So that is VIY is equal to 15 square root of 3 or 25.98 and so on. Okay, so sir, saan ba ditong dalawa, ay saan sa dalawa ang aming gagamitin? Okay, so to lessen the percent error, as much as possible, we will use the exact value of our VIY and our VIX to lessen the percent error of our DX and DY. So to be able to use the exact value of our VIY, we will use 15 square root of 3 meters per second. So that is the value of our VIY. Okay, so next is to solve for our letter B, which is the maximum height reached by the ball. Okay, so since we are looking for the maximum height reached by the ball, so it could be, okay, we already solved for our letter A, which is our VIY, which is 15 square root of 3 meters per second. Okay, So for letter B, what is the maximum height reached by the ball? So I will use the time-independent formula. So since there is no specific time interval during that the moment the object was launched at an angle of 60 degrees. So since there is no specific time interval, so therefore I will use the time-independent formula. And take note, gravity is equal to negative 9.81. So sir, bakit siya equal to negative 9.81? So gaya ng sabi ko kanina, if the movement of the object is upward, so gravity is negative. And if the movement of the object is downward, so gravity is positive. Okay, so always remember that. So since we are looking for the maximum height, so the object is moving upward before it reaches the maximum height. So that is the reason that the gravity is equal to negative 9.81. Okay, so so using time independent formula, because there is no specific time interval, so 2g dy is equal to final velocity square minus the initial velocity square. So gravity is equal to negative 9.81 times dy, which is the unknown, is equal to final velocity, which is 0. Sir, bakit siya 0? So gaya nung sabi ko kanina, if the object reaches the maximum height, so the final velocity becomes or is equal to 0. Bakit? Because there is a certain time where the object pauses for a while or it stops for a while before it starts moving downward. So that is the reason that the final velocity is equal to 0 at the moment the object reaches the maximum height, and then subtracted by the initial velocity y component square. Okay, so simplify. 2 times negative 9.81, that is equal to negative 19.62. Okay, then 15 square root of 3 square, that is equal to 675, times negative, so that is equal to negative 675 meters square over second square. Okay, next is to transpose negative 19. So dy is equal to negative 675 divided by negative 19.62. So if we divide, so that is equal to 34.403 and so on meters. Okay, next is to apply the rule in significant figure. So since we only have one significant figure, so we round this up to one significant figure, and that is equal to 30 meters. So dy is equal to 30 meters. So therefore, the maximum height reached by the ball is equal to 30 meters. Okay, so Tonyo is the best soccer player in the barrio. So if he hits the ball, the score at an angle of 32.7 degree with an initial velocity of 30 meters per second. So for letter A, what distance does he need to hit the ball to have a score of 4 seconds? And for letter B, what is the maximum height reached by the ball during the 4 seconds? So Okay, so to illustrate, so if this is Tonyo, then he hits the ball with an angle of 32.7 degree. So he hit, to illustrate, so if this is Tonyo, he hits the ball at an angle of 32.7 degree with an initial velocity of 30 meters per second. Okay, so for letter A, what distance does he need to have a score? So the distance he need to have a score, so from Tonyo's position, so ito, if this is the goal, okay, if ito yung goal, so ano daw ang position from Tonyo? What is the distance from Tonyo? Ano bang kailangan niyang distance to to have a score for the remaining 4 seconds? So for 4 seconds, ano bang distance from Tonyo's position to the goal? So yan yung letter A. So we are looking for the D sub X. And for letter B, what is the maximum height reached by the ball during that 4 seconds? So during the that 4 seconds that Tonyo is having a score, what is the maximum height? So ito, reached by the ball. So D, are looking for the D sub Y. Okay, so D sub Y for letter B and D sub X for letter A. Okay, so first let us solve for letter A. Okay, so before we can solve for D sub X, first we need the value of BIX. So cosine theta, that is 32.7 degree, times BI, which is 30 meters per second. So that is equal to 25.2453246 meters per second. So ito yung sinabi ko kanina. To lessen the percent error of our dx and our dy, we will use the exact value of our vix. Or pwede rin, okay, para mas short ang inyong to lessen the solution, pwede rin na instead of solving for VIX, you just simply substitute cosine theta times BI to the VIX on the equation of dx. So from dx is equal to VIX times time. So you substitute cosine theta times BI to the VIX on the dx. So just simply substitute. So dx is now equal to cosine theta. So cosine theta, that is 32.7 times BI, which is 30 meters per second. Then times time, which is 4 seconds. So ito, if hindi na necessary or hindi kasali sa tanong kung ano ba ang value ng VIX. So if you are only solving for dx, you can simply substitute cosine theta times VI to your VIX on the equation of your dx. So we input this in our calculator. We have the value of our dx, which is 100.981 meters. So after that, so round to the least number of significant figures. So we have 30, the 32.7, and 4 seconds. So the least number of significant figure is only 1. So from 100.981, we round this to 1 significant figure, and that is equal to 100 meters. So the d sub x, or the distance you need to have a score, okay, so the distance you need to have a score is equal to 100 meters. So that is for the letter A. So we have the same question, so kindly hit the like button if you have the same answer. Okay, so far, maraming nakasagot. Okay, very good. Okay, for letter B, so dito. Okay, so most of these sections has a problem on solving this particular question. So they have a difficulty in answering this question. Most of them has a negative distance. Okay, so ang sagot nila is negative. But hindi naman pwede that we have a negative distance. So it should be positive. Okay, so saan ba sila nagkamali, or what is the problem on their solution? So, okay, so what is the maximum height reached by the ball during the 4 seconds? So, yun yung sinabi ko kanina. This 4 seconds is the total time interval from the moment Tonyo kicked the ball until the, okay, so this 4 seconds is the total time interval from the moment Tonyo kicked the ball until it reaches the goal. So kung ito si Tonyo, okay, so he kicked the ball, then it forms a parabolic parabolic movement. Then ito yung goal. Okay, so this total the whole process is equivalent to 4 seconds. But since we are only referring for the maximum height, so if ito yung maximum height, okay, if ito yung maximum height, so ito yung C, D sub Y. And the maximum height is only halfway of the goal. So kung yung whole duration ng having a score is equal to 4 seconds, then the maximum height is only halfway. So half lang siya ng total time interval. So from 4 seconds, okay, so from 4 seconds, we will divide 4 seconds by 2. Sir, bakit siya kailangan i-divide? So since it is only halfway, or it is only the half of the duration of the total duration of having a score, so we need to divide the total time interval by half. So divided by 2, that is equal to 2 seconds. And 2 seconds, so the time interval on the maximum height is equal to 2 seconds. Okay, so the next question is, ano ba ang gagamitin nating equation? So since we have to choose between time independent and displacement formula, so since it has a time interval given, so specific yung time interval, so we will use the displacement formula, which is the dy is equal to VIY times t plus 1/2 of gt squared. So this is the equation that we will use. So gaya ng sabi ko kanina, the time has to be divided by half, or it has to be divided by 2, and that is equal to 2 seconds. Okay, so since VIY is not necessary, so hindi na it is not necessary to solve for VIY. So we just simply substitute VIY or sine theta times VI to our VIY. So we substitute sine theta to the VIY. So that is sine 32.7 times 30 meters per second times time, which is 2 seconds. Then 1/2 of the gravity, that is negative 9.81, since the movement is upward. And then times the square of time, which is 2 seconds. So that is equal to, if we input this in our calculator, that is equal to 12.7944 meters. And from our given, so 32.7, we have 30 meters per second and also 4 seconds. The least number of significant figure is only 1. So from 12.7944, we round this to 1 significant figure, and that is equal to 10 meters. So dy, or the maximum height, is equal to 10 meters.